Good afternoon, everybody. So this fireside chat, and we'll certainly try to respect the time to leave some room for questions here, is going to focus around the work and, of course, the life of Nicolai Wadstrom. Why don't I start this particular conversation, Nicolai, with a with a very specific question on how did you become a venture capitalist? Start your journey from there.
All right. So, the journey is kind of a long one. I actually did start on the opposite side of the spectrum as an entrepreneur. I'm the kid that got a computer when I was 10, and the games were pretty boring, especially back in the 80s on a Commodore. So I had to learn how to program it to make it a little bit more exciting. Long story short, that turned into entrepreneurship, and I spent my life as an operator building technology companies in different areas of software, from virtual reality to enterprise software, financial trading systems. We took that public in Europe. So that's been my professional path. And then about 15 years ago, I realized that putting smart people together, building a company, if you're a founder or a CEO, it's really about getting everybody that's better than you on the mission, and make sure they're focused, they're passionate, and they can apply themselves. And I realized that as if you invest in entrepreneurs, that's not that dissimilar. It's pretty similar to be able to support them in their journeys. I started angel investments and help other entrepreneurs, and about 10 years ago, I decided to launch BootstrapLabs as a long-term platform to do what I was doing. So that's my journey to the dark side.
That's interesting. So, I want to understand, when you started BootstrapLabs, right, there are so many venture capitalists already chasing deals in artificial intelligence, both in enterprise and consumer space. How do you distinguish yourself? What makes you special compared to other run-of-the-mill VCs that we have, let's say on Sandal Road?
Okay. So when I started BootstrapLabs, actually, this is about 10 years ago. If you look back, that was about the time when Andreessen Horowitz emerged and a lot of other. The past 30 years before that, there has been literally no innovation in the venture capital world. And honestly, I started with the point of my personal mission. I want to be a parallel entrepreneur. I love building companies and finding some of the smartest people and put them together on things that really matter. So I had a personal drive to do it, but I also saw a great opportunity to innovate in this space and bring entrepreneurship into the actual venture capital ecosystem. So with that mindset, launched with a thinking of we want to address some of the biggest, most interesting opportunities in society, basically. And then fast forward about 4.5 years ago, we decided to narrow down solely on applied artificial intelligence, which is our focus today. And honestly, at the time, there wasn't a lot of buzz around AI. Not a lot of people were focused on artificial intelligence then. And it's been around for 65 years since Alan Turing started to put some of the most tangible thoughts around how you build thinking machines. But it hasn't really been applied and scaled to drive real utility. I built neural networks 25 years ago, intellectually stimulating, utility very low, right? But that's starting to change. We saw it in our deal flow. Machine learning actually been applied to see the efficiencies and unfair advantage we like to see. So we actually went ahead of most people with a focus on artificial intelligence. And today we're likely the most active venture capital firm when it comes to AI.
Perfect. So, we'd like to know, as every VC wants to talk about some of the key successful exits that they had as a venture capitalist. We'd love to know some of your successful childs.
Well, we have a lot of successful companies, but we don't have massive exits. So the most valuable companies take a very long time to build. So I'll share a few names. One of the early investments we did before our pure focus on AI is a company called Prezi. They made a tremendous journey. When we invested in them, there were 5 people in the company. Today, they're quite a bit larger. They're beyond. The last round was a growth equity round, so they're beyond the venture scope. They have over 100 million users. They're over 100 times the money since we invested. So that's an amazing journey. They're still private, but I like them to be private because I think they'll be worth 300 to 400 times the money if they keep going a little bit further. So that's one of them. More recent in the AI space, we have companies like Vidora. It's an auto ML company that's doing extremely well, very much ahead of the competition. We have another company called AI. It's a robotic vision company that uses deep learning to actually mimic the synaptic cortex of the brain to drive super effective LiDAR and computer vision technology to understand the three-dimensional world for autonomous vehicles. They just did a B round at a $200 million valuation end of last year. So this is a few examples, but again, venture capital, a decade in venture capital, that's early stage for a venture firm. So we have others that are seed stage companies as well. I see one of our founders here from Fortella, which is a very interesting AI company in the marketing ops space.
Great.
So those are some of the companies, yeah.
Perfect.
We have a lot more, but.
Perfect. So, in the area of applied artificial intelligence, right, of course, leaving aside the consumer and the recommendation and targeting space, more on the enterprise side, what are the areas you think are, really ripe for growth and where the value creation curve will be really high going forward?
And that's a very good question. I'm super biased, of course, because we went all in on artificial intelligence. So I actually do think that every single vertical will be impacted by AI. So think of every single industry vertical. It'll happen. The question is when. And some of them we're seeing sooner than others. Like the health space is very interesting right now. We have a lot of portfolio companies in that space. We co-investors together with Zeta that was just on stage as well in a super exciting company in that space. So I think the health space is very interesting to see a lot of growth opportunity. Operations is very, very interesting in general. And I think then the other way to think about this is also what drives this opportunity. And I want to step back a little bit with that to see where you can look for growth. And just like the mindset is like a lot of the most effective AI companies it's very ambient, right? The product market fit loop doesn't change. The user interface doesn't change just because you use AI, right? So there's a lot of hidden areas where you can just be more effective. And I think we are seeing in the industrial, like boring traditional industry, we have a portfolio company in the construction space. Using AI, they now can build, they're using the camera feeds to build a very quantified view of utilization of excavators, safety evaluations, data that didn't exist at all before for the developers. Now they have a real-time insight into both utilization and the lack of, the wrong utilization of a construction site. It creates massive cost, right? We're talking about billions and billions being lost just because of that, right? So there's a lot of industry areas like that. I think that there's a lot of growth opportunities because the simple fact that we're starting to, with AI, to be able to build inference and reasoning about things that we required humans to do before, and that doesn't scale very well, right? There's a lot of areas.
Makes sense. I'll skip the scalability challenges. I want to talk about what challenges you see regarding adoption of artificial intelligence and enterprise space. So we had Peter Baylis, who basically talked about some of the challenges. We have a panel coming up, which will be moderated by Dr. Sumit Gupta from IBM, which will talk about challenges. Wanted to hear your views coming from a VC. There was an academician, there was an industrialist, or somebody from the industry, and now from the VC perspective, what challenges you see in adoption of artificial intelligence in enterprise space?
So it comes to what we're seeing through our portfolio companies is that one big challenge is there's very little knowledge in enterprises today, and they're fighting for the talent, and they are actually having a hard time to keep up because if it's from Google's to Facebook to others, and startups are most talent in the space, they gravitate there. It's slowly changing a bit, but that's a big challenge for the enterprises. And that hits some other portfolio companies because they're not able to have a counterparty as they sell into them, right? On the other flip side of this, we have, for example, Vidora that I mentioned, which actually applies machine learning to do, to a large extent, what a data scientist does, right? So that helps a lot. It lowers the barrier of entry to start to do this. I think so these are some of the challenges that talent is a big factor. But that's also opportunity, of course, for a lot
Makes
of startups,
sense.
I think.
So I'm going to take a slightly different tack now. So is Lalit here? Who is the person with the mic? I was thinking of actually, in between of this particular fireside chat, open it to the audience for questions, because the first, the keynote and the panel, we could not have really have time. So we'll open it for the audience. We'll again probably come back to some of the questions which we have. So audience, if anybody has any questions that they would like to ask, we can pick them up from here itself. And you can ask anything in artificial intelligence, enterprise AI, recommendation systems, technology, business, anything. Both me and Nicolai will love to answer them to the best of your satisfaction. So anybody who has, yes, sir.
Sure thing. So AI has always been called the fourth revolution, the fourth industrial revolution. In your opinion, what will be the fifth?
Oh.
You want to take it or you want me to take it?
I can start. You can probably quantum computing. Let's say that.
That's a very good way to look at it. I feel that the fifth revolution which will happen, which will not be a new kind of revolution, but actually a conglomeration or agglomeration of different kind of trends. So if artificial intelligence is one of them, but it's really more about simulation of complete human mind. And as you said, quantum computing or nanotechnology is bringing some unique perspective into it. But that's something which we can say it will emerge over a period of time and see where it's going to go. But it's another 10, at least 15 to 20 years away, because AI itself has to, first of all, run through the process, through the stream and get through it. Next question.
Yeah.
Oh, you had something else?
No, I just want to add, there's a very interesting tidbit to this. If you think about AI, one of the reasons it didn't really take off until the last 3-4 years is because we grossly underestimated the amount of compute needed to do this well, right? This little computer has about 100 billion neurons, right? And that scale, we grossly underestimated how much compute power we needed in silicon to even get a fraction of that, right? And that's why, to your point, I think quantum computing can be the catalyst, because there's it's an exponential jump, and when we start to apply some of the things that we're already doing into that context, it will be a game changer of unparalleled proportions, right?
Next question, yes, sir. Vinod Kumar.
Nicolai, I think of one thing, like engineering, for example, the airplane. What is the room there and what is the scope there? Can AI design the airplane the way it looks, for example? And there are so many other applications in the engineering which like AI hasn't been applied.
So why don't you make it more focused upon application of in aerospace engineering, basically, and manufacturing? If you can get the mic.
Good question. I don't know. For aerospace industry, good question. For space, there's a lot, and we already seen that being applied. If you look at, the Mars rover project would not have been possible without artificial intelligence, and sophisticated system can reason and do inference, right? So if you're thinking about, if you go to space, aerospace, of course, like autonomous flight will have a major impact. But there's a lot of other factors. Energy, ability to build, highly efficient, smaller vehicles, short distance. I think we'll see a lot of innovation. That will drive a lot of it. But autonomous flight, but there's a lot of challenges, regulatory and others before we are there. That will take 10, 15 years, I think. But
and I will go a little bit more specific into aerospace engineering, hydrodynamics or hydraulics. If you look into designing of these aeroplanes, right, you use these finite element methods or numerical methods driven models which are used for designing the systems. What can happen over a period of time is, right now, the existing mechanisms can only do so much of analysis in a given period of time. When you have huge amount of data coming in, we can actually have much better simulations at a much higher level, and some predictive models can be built into it from the fact that whatever has, let's say, crashes have happened in the past or accidents have happened in the past, that data can be much more widely used for designing systems based upon where they are going to be deployed. So that is something which will come in. Another aspect of it is when you're designing the systems, you actually want, when manufacturing is done, you want to make sure that it's error-free. So when designing these systems, we can design it in such a way that the data can be collected much more easily, and the system is built in such a way that real-time data feeding can be done and predictive analytics can be done. These are some of the areas where we can grow in aerospace engineering.
I think a lot of the things we've done in aerospace through virtual reality and simulations. I started a virtual reality company in 1996, so I worked a lot with defense and others at the time. So that was a major leap in efficiencies once we started to simulate the airplanes, right? All of a sudden the wings fit. This is something people don't think about. Before we started to do virtual reality prototyping, you had to adopt a lot of things you would, scary when you hear it, that the wings wouldn't fit until you adjusted them. But there's a lot of things that were hard to predict when you did engineering. It was so complex. A lot of those things, I think we'll be able to move into actually AI models to rapidly simulate and predict. So same thing in the cockpit, right? As you said, errors of the new the planes that we've been seeing, right? Maybe we can predict that this could be a risk factor ahead of time.
And then the amount of human errors which actually happen can be reduced with systems automatically responding to it by designing them in a way, by leveraging what has happened in the past to make them more automatic. The only thing which is typically tough, I'll tell you, are human emotions which you can't model. What you can do, you can minimize errors due to human models, computer models to minimize human emotions and errors because of that. Next question.
I have a question about investment in the AI space. Two parts. So one is, do you see more of it happening in the AI capabilities, deep tech, or do you see more of it happening in applied AI in domains like whatever, fashion, retail, this, that, and so on and so forth?
Okay.
Second part, different question, is the way AI companies develop is a little bit different from the way, for example, software companies or even previous generation hardware companies develop. It's a much faster cycle with a lot more pivots and usually with shorter time to completion and exit and all of that, or break even, whichever way. Now, do you think that the way venture investing happens today is fine, or does it need to change to adapt to that?
Yeah, the first one is easy to answer. The second one, I'm not sure I understand really. I'll try. Okay, so the first one it's pretty simple. We are only focused on applied artificial intelligence, and that's because we like the vertical integration. We like to invest in the next Google that actually apply the technology and harness the value themselves versus selling the technology, right? So we're focused on applied AI piece. We haven't done anything in fashion. I don't know if we will. Aerospace, not yet, but maybe we will, right? But that said, I think there's a few exceptions. We also invest in a company that build deep learning silicon chips, right? Deep learning processing units. So we do that. On our end, the majority is applied AI, and then some of the others. I think over time, that's where most things will happen, because I think AI is as ubiquitous as the internet, right? It will go everywhere over time, right? So that applied AI is where it is.
And I will add something to it, and Nicolai, you can please correct me if I'm missing something. VCs also have to change their mindset a little bit when they're investing in AI companies. Typically, VCs like to invest in product companies, not services companies. But AI-related startups, especially in enterprise space, in the beginning when they're ramping up, they will have to have a bigger services arm because products are not going to be so easily adopted. And from the cold start problem that you see, you basically have to collect some data from that, couple of new customers, and deploy more services people. So, you'll have to have a little bit more, what I would say, room to wait a little longer sometimes. And the return that you get on the services side is typically not high compared to the product side. So a little bit of the product service mix, the dynamics will change, and VCs will have to basically manage their investment thought process.
Yeah, I think that's true, but that's really going back to the question about enterprise. There's a land grab for talent. Like, people are understanding that this is make or break. And I see a lot of C-level executives from across the globe. 18 months ago, AI is very interesting. We should look at it. 6 months ago, I almost see fear in their eyes that we don't have a strategy how we deal with this, and it's going to kill us unless we do, right? So there is a land grab for talent, and the ones that really figure this out, I think it's good to remember, like we had Google on stage, they switched to an AI machine learning driven model 2013. Think about that. Who talked about machine learning back then? Google didn't say anything, right? They did, and they also had some of the biggest, probably the biggest supercomputer on the planet. So they had to compute to do this, right? And they saw the patterns early. I mean, going back to this, there is a land grab of talent, but as a VC, we're very focused on products, right? So people have all different strategies. But I have a slide for ILPs when we talk about raising money for our funds, right? On one end, I have DeepMind, $400 million exit. Mobileye, $15 billion. I want to do this every day of the week. 15 billion, not 400 million, right?
And if you do a couple of those exits, you'll never be coming here again, I suppose. No?
Sorry, if I...
You'll never be again coming here. I mean, once you...
I'd love to come back. I'll come back and talk about that journey then.
Absolutely. So, guys, we'd like to continue this since we have some more time. We'd like to continue this trend. Anybody can ask any question in AI and technology, business, in any space, vertical. We'll try our best to answer. Yes, sir.
So how real are self-driving cars?
So, my answer sometimes is, why don't you go with a thought, and based upon how you feel, we'll decide it. If you were to step back and think about autonomous driving, and from artificial intelligence perspective, there are 3 or 4 different components that go into designing an autonomous vehicle. Number one, the first part of it is basically image recognition and understanding where you are. Second is contextual analysis to understand the background in which you're seeing things. Third is basically looking into from the perspective of reacting, whatever has happened, your response systems. You also then have some entertainment systems which go into building this particular infrastructure. And all of this has to be done remotely. It needs to be controlled and worked our way through it. I'll give you a very simple answer because we have gone through, as I said, I run this artificial intelligence forum for IITians. The best place for autonomous vehicles to start is slow-moving commercial carriers in places like shipyards and mining fields, where you don't have much other traffic, you have defined lanes, and you start with self-autonomous vehicles. That's the best place to start, safe and sweet. Once you have a good amount of track record and data over a period of time, then you can move to other kind of commercial vehicles which run on very defined tracks with not much of traffic intervention. And then comes, and we can think about exploring, general commercial traffic vehicles. Remember one thing, our new electric cars and stuff like that, they already have a lot of autonomicity built into it. So on one side, that's the phase in which that needs to happen. On the other side, it will be about building autonomous capabilities into the car one step at a time, where you don't replace the driver completely. So 2 things will happen over a period of time, and it will take some substantial amount of time. The reason is the risk, the challenge, the drawback is a human life. So you'll have to think in a different way. Nicolai, your chance.
Okay, so I'll say this. The technology is very real. It's going to take a little bit of time before we get there. I think that this is a good way to quantify this. You need to train these systems quite substantially to make them safe. There is a consensus. We have a lot of people close to us in the US government and others that look at regulation and other things around this. There's a consensus that you need about 3 billion miles of sensory data, of training data, to get a commercial grade, safe, self-driving car. Google, this is rumors. If anybody from Google, they correct me or say that they don't disclose it, but they are probably at 10 million miles in sensory data. They need to get to 3 billion, right? So the answer is very simple. Long story short is look at what Unity is doing of actually creating a virtualized environment where we actually train our AI systems. That's the path, and a lot of people are working on tangible solutions to do this. And this does not just apply to self-driving cars, it applies to a lot of other things, robots for mines or for whatever you could think of. That's the path, and we need to work a lot more because before these systems are solid. The biggest stop will be regulatory, I think. Going back to what you said, human lives and accountability. We don't really have frameworks to how to look at accountability and so forth yet. It will emerge, but that will take time. So I think going back to, I'm reinforcing what you said, areas where you can exclude the general public becomes really tangible. Those are also, there's some very interesting areas when we talk more widely about autonomous vehicles. Think about really harsh environments. oil rigs and other things, where actually you can now make sure you make things much safer because you don't put humans at risk, right? That's where we'll see a lot of adoption of autonomous vehicles in different shapes and forms early, I think.
Perfect. So guys, we are up the time, and since I'm one of the organizers, I will stick to the time for sure. Thank you, everybody. We have a great panel coming up.
Thank you.
And thanks, Nicolai, for coming here. This was
Thank
fun.
you. Thank you so much.